It's 11 o'clock, so I guess we'll get started. Thanks everyone for coming. My name is Brian White. I'm the Director of Solution Engineering at Sonatype. And my talk today is Certify Once, Secure Always, fast-tracking trusted software to the mission's edge. Just to give you a little background on Sonatype, as an organization, we've always been focused on helping organizations leverage open source software securely. Our founders were core contributors to the Apache Maven project. They founded Maven Central, and we are the stewards of Maven Central today, which is the home for open source for Java. We provide a platform which allows organizations to set policies around the open source that they're leveraging and to make sure that they're able to securely leverage open source effectively and deliver their software at scale. We're serving tens of thousands of developers across the DoD, intelligence community, and civilian agencies. And with some early funding from In-Q-Tel, we were able to develop a air-gapped environment, which we call SAGE, Sonatype's air-gapped environment, which allows us to provide the same capabilities that we have on the low side for your high side environments as well. So as I said, we've been at this for quite a while. In fact, Sonatype has been publishing this report called the State of the Software Supply Chain Report for 10 years. That is a safe QR code, but you can just use the link if you don't feel safe clicking on a QR code. I would recommend checking out the State of Software Supply Chain Report. It is a very data-driven report and shows you a lot of information about how open source is being consumed, the types of attacks we're seeing, all about the different types of behavior that we're seeing across the different open source ecosystems. Now this slide just talks to the rate of adoption of open source, which is massive, right? We're almost at 7 trillion. Probably the next time this report comes out, we're going to be over 7 trillion across. This is just across the 4 most active languages, right? And as you can see, Java, which is run by Maven Central, that's the one Sonatype runs. That's the second largest open source ecosystem in the world. And it makes sense why there's so much adoption of open source. It's kind of the whole adage of why recreate the wheel. If someone is providing capabilities for free that you can leverage to speed up the process of building your applications, why wouldn't you take advantage of that, right? It just makes really good sense. It's like engineering improves as it builds on other engineering. The thing that I like to say to my customers is, you're getting all this functionality and all this capability for free in your applications. Your role is in the technical debt, making sure that you're picking the right open source packages and you're maintaining them and upgrading them as you need. That's really where the challenge for organizations are to safely adopt and leverage open source in their applications. Now, Gartner recently stated that if you take a modern application, 90% of it is open source components. So literally, if you broke open that app, 90% of what would fall out would be open source packages, right? So it is by far the largest footprint in your modern applications is its different open source components that are being leveraged. And as we've all are probably aware, they can be susceptible to attack, right? So I want to kind of get clarification and talk about the difference we have between a vulnerability and malware, right? And both are things that are very prevalent in open source, right? A vulnerability is a mistake, it's an accident. No one intentionally was embedding something in that package that could be exploited. But they overlooked something or are unaware of some type of setting that was there, and they left themselves open to attack, right? And this is kind of traditionally the types of attacks you see are taking advantage of these types of vulnerabilities. What we've been seeing for the past 5 years is a very steady increase in malware intentionally being published into open source ecosystems, and with the attempt to trick your developers or your build environments to automatically pull in malware directly into your environment. And the important thing to keep in mind with the malware is its intent is to do harm, right? And we've seen malware that does minor things from protestware all the way to drop ransomware, exfiltrate your credentials, crypto miners, you name it. All the types of things you are concerned about in security can be deployed simply from an open source package. So taking a look back at kind of the evolution of supply chain attacks, right? The original attacks we always saw were, bad actors taking advantage of vulnerabilities when they were identified and looking for exposed servers. Log4j is the most recent example of this. Is anyone here involved with had to do with Log4j when it happened about 3 years ago? It ruined a lot of people's Christmas holidays. Like I said, this was very common, right? It still happens, but bad actors aren't waiting for that anymore, right? They're finding ways to inject themselves into the CI/CD pipelines and to really hack into the system, right? And it's becoming more and more prevalent. So let's start by first talking about persistent vulnerability risk. As part of our State of the Software Supply Chain report, Sonatype looked at Maven Central. And we looked at every single component that had a known vulnerability associated with it, and then went to see if there was a fix for that particular vulnerability. And what we found is that 95% of all packages that were vulnerable had a fix available. So only 5% had a non-fixed version of that component. So I would say that the maintainers are doing a pretty effective job of actually staying up to date with known risk associated with their packages and actually remediating that software. However, when you look at the consumption side, what we saw was that 62% of the downloads were to vulnerable versions, even when there were fixes available for those specific packages, right? And this is only happening because organizations or developers don't have effective tools to help them make better decisions about what open source they should be bringing into their environment and how to remediate these vulnerabilities, when they're identified. So I guess my message is this problem is very avoidable. When it comes to that persistent vulnerability risk, if you have the right solutions and the right tools, you can very effectively use open source very safely. And the maintainers do a very good job of keeping their projects up to date. So now let's take a look at open source malware. So this comes directly from the State of Software Supply Chain report that came out last fall. At that point, Sonatype had identified over 704,000 known malicious packages that have been published to open source ecosystems. And as you can see, it started really small in 2019, and it's had a very very high spike as far as the growth of these types of packages. We put out a report last quarter which said that in Q2, we had actually seen an increase of 188% of malware being published to open source from the same time last year, which equated to over 16,000 packages of malware being published to all the different open source ecosystems. In that same time, Sonatype was able to successfully block over 88,000 packages from getting into our customers by leveraging one of our solutions called Sonatype Repository Firewall, which actually proactively can protect you from these malware types of attacks, even zero-day attacks. And as of July, that is our total count of the malware we have identified across the different open source ecosystems, right? 845,000 packages. So large language models, AI, ML, this is kind of the hottest topic now. And what we're seeing is, from our perspective, this completely mimics open source behavior. It's community driven. It brings risk like security, legal risk, even ethical risk. But it's going to help you make much more sophisticated apps. So it's such a multiplier as far as capability that organizations in general can't ignore it, and they're going to very quickly adopt, the AI, the large language models. And they're already getting hacked, right? So we identified this type of attack at the beginning of the year, and it's basically took advantage of the pickle files that are being leveraged within the models for serialization, deserialization, and enabled, these models to be hacked. And that's just going to continue. We expect to see this is going to be a very fertile ground for attacks as far as, these large language models. So when you talk about the risks of leveraging AI ML in your organization, these are all the types of things you have to be concerned about. There's going to be legal risk associated with licensing, things like that. You're going to have to worry about malware, right? Potentially data loss or sensitive data exfiltration. You have to worry about even just the quality of those models that you're using. Is it printing out messages that aren't safe for work, things like that? So there's just a whole set of different risks, and as an organization, you need to have a strategy about how you're going to manage, all these applications, because you want to be able to leverage these models to improve your applications, obviously. So in order to do that, you need to make sure that you have visibility into which models you're using. Are you using the definitive model or is it a derivative model, right? Where is it being used? What kind of qualities does it have? Do I have any risk of any inappropriate language or bad licensing associated with that? So these are all things that when you talk about kind of the new Swiss initiative from the DoD, it's really focused on making sure organizations are able to quickly adopt secure software delivery, so that you can still leverage these capabilities, but make sure you're delivering them in a safe and effective manner, right? And it requires different types of artifacts and different types of capabilities in order to do this. Things like a software bill of materials, right? So that when you're delivering software, you can let people know, your customers know exactly what you're delivering as far as open source, and they have a way they can actually monitor it and know if there's any risk associated with it. You want to be continuously doing security scans as part of your build process, right? So that when new vulnerabilities pop up, you can go and remediate them. So at Sonatype, we supply a platform which really integrates at all stages of your software development lifecycle. So as you stated, we are the stewards of Maven Central, so you get that for free, right? So that's our gift to open source, all the Maven packages you want. And we developed a Nexus repository, which is leveraged by over 150,000 organizations. And this is a centralized warehouse for you to house all the open source packages that you're leveraging. So when you pull them in, you now have a local cached copy of those packages. It helps to speed up your builds. It also makes sure they're always available, so you can always build your applications. 2 weeks ago, there was a very popular package in NPM that the developer removed, and build pipelines were failing all over the world because of it, because the organizations didn't have their own copies of those packages, so they could always make sure they could build their applications. And that's kind of what Nexus repository provides for you. It makes sure you always have those parts you need to build your apps. It's also a centralized location for you to publish your build artifacts when they're done, and then monitor them as they move through the different stages of your build process, so you always know at what point is this. Is it just gone through build? Is it done QA testing? Is it ready for production, etc.? And it all gives you a centralized location with RBAC control. We developed what we call a repository firewall. This is not like your network firewall. It's focused completely on looking at each individual open source component as you're pulling it in and making sure that it meets your policies. It allows you to actually set a perimeter about the open source components that you're pulling into your environment, and you can actually quarantine automatically components that don't meet your corporate policies, right? So is it a component which is severely vulnerable? Does it have a really bad license obligation that I don't want to allow my developers to leverage? Or is it malicious or suspicious? Is this something that was published 5 minutes ago and you're trying to pull into your environment and it's never been vetted? Right, so our repository firewall gives you that capability to actually set that perimeter and prevent that net new risk from getting into your environment. And then we have a product called Lifecycle, which now will scan your applications and generate that software bill of materials, or SBOM, and continuously monitor that SBOM, so you know when new vulnerabilities are popping up, exactly where they are, which applications are using them, and we provide the remediation guidance as well. And behind all this comes with what we call Nexus Intelligence, where the data we provide is curated. So our data research team actually digs in and validates when vulnerabilities are introduced and when they're remediated, and make sure that the data is very accurate to eliminate the false positives and negatives. And then we have SBOM Manager. This is a kind of a compliance solution that helps you manage now all those SBOMs you're getting from vendors or even your own SBOMs. So when you're getting third-party software from a vendor and they deliver an SBOM, which is now a mandate, I know in DoD and definitely in Army, what are you doing with those SBOMs to make sure that they just going in a file system? With SBOM Manager, you have a way to ingest them, see the risk. It allows them to annotate to see, whether they're susceptible to that risk, and then you can continuously monitor their SBOMs and know when a new vulnerability pops up in their application that you've installed in your network. So you can go back to them and say, when you're going to remediate this. It also gives you a place to manage your own SBOMs that you're delivering to your customers and annotate them as well. And of course, we support this in self-hosted, so you can host it on your server and your GovCloud, et cetera, but also with our air-gapped environment, right? So the whole idea is that we provide the same capabilities for the low side as the high side, so there's no confusion, right? Everyone has the exact same tools when they're developing software. So based on the SWFT requirements, this is kind of where Sonatype is able to help you fill those requirements. As far as SBOM generation, we got that covered with our SBOM Manager and Lifecycle, risk-based policy enforcement, also with our firewall and Lifecycle, the ability to have trusted components sourcing, right? So we can tell you that it is coming from a definitive source, right? That this component, because we do everything hash-based, we know came from Java for NPM for JavaScript or PyPI for Python or Maven Central, for example. You know exactly what was the source of that package. And we provide audit-ready reports as well to help you meet your SWFT needs. Now, one of the things we like to talk about when you talk about SBOMs, it's just a natural thing that should be happening in the software industry. Anyone here who flew here would expect that your plane was fully inspected, before it was delivered to an airline, right? Not just 50% of the parts. You expect them to know exactly what's there and have the ability to recall when there's a particular problem. If you look at agriculture, even if there's something wrong with lettuce, we know how to recall that. For some reason with software, it's been a black box for so long, and now this is kind of opening up the curtain so people understand exactly what is in the underlying software. And if they're being put at risk because of the software practices of the vendor that is supplying them. So Sonatype is widely leveraged across the federal government. So you don't have to worry about being an early adopter when it comes to leveraging our solutions. We're heavily leveraged in the intelligence community, Air Force, Navy, and in multiple commands within the Army as well. And we can support, with our air-gapped environment, we can support IL6, IL6 Plus, and that's already happening right now. We have customers doing that. But on the low side, we can support NIPA requirements as well. Really can give you the full capabilities that you need to have a safe DevSecOps program and to leverage open source safely. And then my final slide, Sonatype has been recognized as the leader when it comes to software composition analysis. This came out last year, and I've heard that the new one is coming out, and we've also been recognized as the leader there as well. I haven't seen it yet. But this is based on not only just our strength of our current offering, but also our strategy going forward, is that we're recognized at this level. And this is my final slide. Come visit us at booth P18. We have cookies and yo-yos and stickers. Happy to give you whatever you like. I think I might have a minute or two if there's any questions, or you can just come visit as well. All right. Thank you all. Appreciate it.